Hi, Year 11. Do now some probability and sort of statistics-y kind of stuff. Okay, you've got 5 minutes. I think it's all pretty self-explanatory. So have a go at everything. Remember, don't just ignore a bit. Have a go, even if you get it wrong. But then, so important that we're watching the solution and listening to it and correcting that work that you've written down. Don't just do the whole thing in your head. Write it down and then correct it as well. If you need to, you might just get it all right, which is great. Okay, 5 minutes starting now. Cool, time's up. Let's go. Right, a bag contains 10 discs. Each disc is labelled with a different number from 1 to 10. So we've got our discs here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different ones. A disc is chosen at random. Find the probability that the chosen disc is the number 3. Well, there's only one number 3 in there, so it's 1 out of 10. You can give your answers as either a fraction, a decimal, or a percentage. So you could do, it could have been 1/10, could have been 0.1, or you might have done 10%. Any of those things are correct. Okay, now I'm going to stick to fractions for this, but if you've got the equivalent, then that's fine. A number less than 4, well, that's 1, 2, and 3. There are 3 of those out of 10. Again, that could be 30% or 0.3. Square numbers, right, your square numbers, get a different pen on this. Square numbers are 1 times 1 is 1, 2 times 2 are 4, 3 3s are 9, 4 4s are 16, and, well, we've run out of numbers. Now, 1, 4, and 9 are in there, and they are, of course, 3 of them. So again, that's 3/10. So again, 30% or 0.3. Prime numbers. Okay, the prime numbers are 2 is the first prime number, then 3, then 5, then 7, then 11. So we've gone outside of the range of our numbers. So 2, 3, 5, and 7. There are 4 of them. So 4 out of 10. Anything that's equivalent to that is fine. 40%, 0.4, or 2/5. Any of those are absolutely fine. A bag contains 8 blue, and 5 red counters. That's a total of 13 counters. A counter is selected at random. The colour is noted, then replaced. Okay, draw a probability tree for this. So firstly, I need some branches for selecting blue counters. I need some branches for selecting red counters. Now, I have 2 sets of branches here. This first set, that's for the first counter I select. Now, the fact that it's replaced is really important, because then when I then go to draw my second counter, which is this second set of branches, the probabilities will be the same as the first ones, because it's been replaced. I've still got the same amount of counters in there. Now, you put the labels at the ends of the branches for these, and then the probability goes along the branch. Usually we would do a fraction, but it could be a percentage or a decimal. Fractions are definitely the easiest here. For a blue, well, there are 8 blue out of 13 counters, so that's your fraction, 8/13. And there are 5 red, so it's 5/13. Now for the second set of branches, it's actually the same probabilities, because you put even if you came up this way and selected a blue the first time, you put the blue back in, so there are still 8 out of 13 blues, and there are still 5 out of 13 reds. And same for these ones down here, 8 out of 13 for the blue, and 5 out of 13 for the red. Hopefully yours is a bit neater, mine's a bit cramped down here, a bit shorter space. Probabilities along the branches, labels at the ends. Now, a frequency tree is slightly different, partly because a frequency has nothing to do with probability in this case. It's just another word for how many. So in each little bubble here, there is like the total. So this first one is the main total, and then some people have got a morning appointment or an evening appointment. So 23 people did the morning, which means this side must be enough to add up to 40, because the 40 gets split down these 2 branches. So there are 17 people that had an evening appointment, and then it looks like of the morning people, 21 were on time, good for them. Late must be 2. Well, it must be 2 because these 2 bubbles here must add up to the previous total. The total just gets split. We don't lose anyone along the way. They must be accounted for in a bubble somewhere. Now, for the evening appointment, there were 17 people. 5 were late, which means there must be 12 that are on time, because again, they must add up to the previous total. And if I added up these end ones here, they should all add up to the original total of 40. We haven't lost anyone along the way. Okay, cool. Right, off to your main task then. Bye-bye.